Start your engines and grab your morning brew, whether it's coffee or tea, because today's Auto Intelligence episode is something truly special. I'm Steve, and I'm here with Claire, and we're both part of the Auto Agentic team, bringing you this celebration of the minds who made everything we discuss on this show possible.
That's right, Steve. Today we're stepping back from the latest automotive AI headlines to honor 5 extraordinary individuals whose groundbreaking work laid the foundation for every autonomous vehicle, every smart manufacturing system, and every AI-powered innovation transforming mobility today.
Auto Intelligence is produced by Auto Agentic AI, and we drop new episodes every Tuesday, Thursday, and Saturday. But this episode, this is our tribute to the Titans, the 5 most influential minds in artificial intelligence history.
And when I say influential, I mean these are the people whose work directly enables Tesla's full self-driving, powers Mercedes' Drive Pilot system, and makes it possible for your dealership's AI agents to understand and respond to customer needs in real time.
Before we dive in, I want to thank our growing audience. The feedback we're getting from dealers, manufacturers, and mobility innovators has been incredible. Your enthusiasm for understanding how AI is reshaping automotive retail keeps us motivated to bring you these insights.
So let's start with a thought experiment, Steve. Imagine you're driving down the highway and your car is making thousands of calculations per second, recognizing pedestrians, reading road signs, predicting the behavior of other vehicles. That's not science fiction anymore. It's happening right now thanks to the 5 individuals we're celebrating today.
Our first Titan takes us back to 1912, when Alan Turing was born into a world where the closest thing to a computer was a mechanical calculator. Yet this man would conceive ideas so advanced that we're still building upon them today.
Alan Turing is often called the father of computer science and artificial intelligence, and for good reason. In 1936, think about that, Steve, 1936, he described something called the Turing machine, which was essentially a theoretical blueprint for every computer that would ever be built.
That's fascinating because when you think about the computers running autonomous vehicle systems today, they're all fundamentally based on Turing's concept. But what really gets me excited is his 1950 paper, Computing Machinery and Intelligence, which introduced the Turing Test.
The Turing Test was brilliant in its simplicity. Turing asked, if a machine could engage in conversation indistinguishable from a human, would we consider it intelligent? Today, when your customers interact with AI chatbots at dealerships, or when voice assistants in vehicles understand natural language commands, they're all being evaluated by variations of Turing's original test.
But here's what really demonstrates Turing's genius. During World War II, his work breaking the German Enigma code is estimated to have shortened the war by several years and saved over 21 million lives. He proved that computational thinking could tackle problems that seem to require pure human intuition.
And that's exactly what we see in autonomous driving today. When a self-driving car encounters an unexpected situation, maybe a child chasing a ball into the street, it's using the same kind of computational thinking Turing pioneered to make split-second decisions that could save lives.
What strikes me most about Turing is his vision. In 1947, he said, "What we want is a machine that can learn from experience." Steve, that's machine learning described 77 years ago. Every time an autonomous vehicle's AI improves its performance based on previous drives, it's fulfilling Turing's vision.
Tragically, Turing died in 1954, just as the computer age was beginning, but his theoretical foundations made everything that followed possible. Without Turing's work, there would be no neural networks powering vision systems, no machine learning algorithms optimizing traffic flow, and no AI agents helping customers find their perfect vehicle.
Our second Titan brings us into the modern era of AI. Geoffrey Hinton, born in 1947, is universally known as the godfather of AI, and his work directly powers the computer vision systems in every autonomous vehicle on the road today.
Hinton's most transformative contribution was his work on the backpropagation algorithm in 1986. Now, that might sound technical, but here's why it matters for automotive. This algorithm is how neural networks learn to recognize objects, predict behavior, and make decisions.
Think about it this way. When your Tesla's autopilot distinguishes between a plastic bag blowing across the road and a small animal, that's backpropagation at work. The system has learned from millions of examples, adjusting its internal parameters to make increasingly accurate predictions.
But the real breakthrough moment came in 2012 with something called AlexNet. Hinton's student, Alex Krzyzewski, created a neural network that dramatically outperformed all previous image recognition systems in the ImageNet competition. This victory essentially launched the current AI boom.
That 2012 moment was pivotal for automotive AI, Claire. Suddenly, everyone realized that deep learning could achieve superhuman performance on visual tasks. That's when companies like Google, Apple, and traditional automakers started pouring billions into autonomous vehicle research.
And just this year, Hinton received the Nobel Prize in Physics alongside John Hopfield for their foundational work on artificial neural networks. The physics community recognized that their innovations drew from statistical mechanics to solve information processing problems.
But here's what I find most compelling about Hinton. Despite being the architect of modern AI, he's become one of its most thoughtful critics. In 2023, he resigned from Google specifically so he could speak freely about AI safety concerns.
That takes real courage, Steve. Here's someone whose life work enabled the AI revolution, and he's now warning us about the need for responsible development. When we think about autonomous vehicles making life and death decisions, Hinton's concerns about AI safety become incredibly relevant for our industry.
His transformation from AI architect to AI ethicist reflects the profound implications of the technologies he helped create. Every time we discuss the importance of explainable AI in automotive applications or the need for robust testing of autonomous systems, we're grappling with the very issues Hinton is raising.
And that's particularly important in automotive, where public trust is everything. Consumers need to understand and trust the AI systems in their vehicles, and Hinton's advocacy for responsible AI development provides a roadmap for how our industry should approach these challenges.
Our third titan, Yann LeCun, born in 1960, revolutionized how machines see and understand the visual world. His work is literally embedded in every camera-based safety system, every parking assistant, and every autonomous vehicle on the market today.
LeCun's defining contribution was the development of convolutional neural networks, or CNNs, in the late 1980s. Unlike traditional neural networks that treated images as flat arrays of pixels, CNNs preserved the spatial structure of visual data.
Here's why that matters for automotive applications. When an autonomous vehicle's camera system identifies lane markings, traffic signs, or other vehicles, it's using LeCun's CNN architecture. The system detects local features like edges and textures, then combines them to recognize complex objects.
The practical impact was immediate. LeCun's handwritten digit recognition system was deployed by banks across America, processing over 10% of all checks in the United States during the late 1990s and early 2000s. This proved neural networks could solve real-world problems at massive scale.
That's exactly the kind of scale and reliability we need in automotive applications. When Mercedes-Benz deploys Drive Pilot on thousands of vehicles, or when Tesla pushes a full self-driving update to millions of cars, they're relying on the same principles LeCun established decades ago.
Currently, LeCun serves as chief AI scientist at Meta, where he's pushing the boundaries even further. His latest focus is on self-supervised learning, systems that learn from raw, unlabeled data, much like humans do through experience and observation.
That's incredibly relevant for autonomous vehicles, Claire. Instead of requiring engineers to manually label millions of driving scenarios, self-supervised learning could allow vehicles to continuously learn from their everyday experiences on the road.
The 2018 Turing Award, which LeCun shared with Hinton and Bengio, recognized their collective contribution to deep learning. But LeCun's specific focus on visual intelligence has enabled applications ranging from medical image analysis to the computer vision systems that power autonomous vehicles.
And when we think about the future of mobility, whether it's vehicles that can navigate construction zones they've never seen before, or AI systems that can interpret complex urban environments, we're talking about advancing the visual intelligence foundations that LeCun established.
It's worth noting that LeCun also co-created DJVu, a document compression technology that became essential for digital libraries. This shows how AI research often has unexpected applications across different domains, just like how automotive AI innovations often find applications in manufacturing, logistics, and other industries.
Our fourth titan, Yoshua Bengio, born in 1964, represents the theoretical heart of the deep learning revolution. As the most cited computer scientist globally, his influence permeates every aspect of modern AI research.
Bengio's theoretical contributions to neural machine translation transformed how machines process language. His work on attention mechanisms and sequence-to-sequence models enabled breakthroughs that directly impact automotive applications today.
Think about voice assistants in vehicles, Claire. When you tell your car to navigate to the nearest electric vehicle charging station, the system uses attention mechanisms pioneered by Bengio to understand the meaning and context of your request.
The attention mechanism became a cornerstone of transformer architectures that power systems like ChatGPT and GPT-4. In automotive contexts, these same principles enable natural language interfaces that allow drivers to interact with their vehicles conversationally.
Bengio's research into the fundamental principles of deep learning address critical questions about why neural networks work and how they can be improved. His investigations into representation learning and unsupervised learning provided theoretical frameworks that guide practical developments across our industry.
As founder and scientific director of MILA, the Montreal Institute for Learning Algorithms, Bengio created one of the world's premier AI research centers. MILA has produced numerous influential researchers and breakthrough technologies, establishing Montreal as a global hub for AI innovation.
What I find fascinating is MILA's interdisciplinary approach, combining computer science with neuroscience, linguistics, and philosophy. This reflects Bengio's belief that AI must draw from multiple fields, something we see in automotive AI, where successful systems combine insights from engineering, psychology, and human factors research.
Recently, Bengio has pivoted toward AI safety research, concerned about the potential risks of artificial general intelligence. He's become a leading voice for responsible AI development, working on AI alignment to ensure future systems remain beneficial and aligned with human values.
That's particularly relevant in automotive, where AI systems make decisions that directly impact human safety. Bengio's work on ensuring AI systems behave predictably and safely provides crucial guidance for how we should develop and deploy autonomous vehicle technologies.
His involvement in drafting the Montreal Declaration for Responsible AI Development reflects his commitment to ensuring that AI benefits all of humanity. Through his teaching, mentorship, and public engagement, Bengio has shaped not just AI technology, but also how society approaches its development.
You're listening to Auto Intelligence, brought to you by Autoagentic, the platform transforming automotive retail with intelligent, human-centered AI. Our modular agent approach helps dealerships streamline operations while maintaining that crucial human touch that builds lasting customer relationships.
What sets Autoagentic apart is our understanding that true agentic AI isn't just about automation. It's about strategic thinking and collaborative planning that amplifies human expertise rather than replacing it. That's why we're known as the most human AI company in automotive retail.
Now back to our celebration of AI's founding fathers and their impact on mobility. Our fifth and final titan, John McCarthy, born in 1927 and passing in 2011, holds the unique distinction of not only naming artificial intelligence, but establishing it as a legitimate scientific discipline.
McCarthy's most enduring contribution was coining the term artificial intelligence at the famous Dartmouth Conference in 1956. Along with Marvin Minsky, Alan Newell, and Herbert Simon, McCarthy organized this gathering that officially launched AI as an academic discipline.
The conference proposal was remarkably bold for its time, stating their intention to test the assertion that every aspect of learning or any other feature of intelligence can be so precisely described that a machine can be made to simulate it. That vision is still driving automotive AI research today.
But McCarthy's practical contribution was equally important. The Lisp programming language developed in 1958. Unlike other programming languages designed for numerical computation, Lisp excelled at symbolic processing and manipulation of complex data structures.
Lisp became the dominant tool for AI research for decades, and its influence persists today. The ability to treat code as data, which Lisp pioneered, enabled AI researchers to create programs that could modify themselves, a crucial capability for machine learning systems.
McCarthy's theoretical contributions extended to fundamental concepts in AI reasoning. His 1958 paper on the advice taker outlined a program that could accept new information and use this knowledge to solve problems, laying the foundation for expert systems and knowledge representation.
At Stanford University, McCarthy founded the Stanford Artificial Intelligence Laboratory, or SAIL, which became one of the world's leading AI research centers. SAIL pioneered research in robotics, computer vision, and natural language processing, training generations of researchers.
Many of those researchers went on to establish AI research programs at universities and companies worldwide, creating the global network of AI expertise that enables today's automotive innovations. The institutional framework McCarthy created made sustained, collaborative AI research possible.
McCarthy's influence extended beyond AI to general computer science. His work on time-sharing systems enabled multiple users to interact with computers simultaneously, a concept fundamental to modern computing and cloud-based automotive services.
His contributions to the ALGOL programming language influenced virtually all subsequent programming languages. When software engineers today develop AI systems for autonomous vehicles, they're using programming concepts that trace back to McCarthy's foundational work.
As we reflect on these five titans, Claire, what strikes me most is how their contributions build upon each other. Turing established the theoretical foundations, McCarthy created the institutional framework, and the three godfathers, Hinton, LeCun, and Bengio, delivered the practical breakthroughs.
Exactly, Steve, and their collective impact on automotive goes far beyond the obvious applications. Yes, their work enables autonomous vehicles, but it also powers predictive maintenance systems, supply chain optimization, personalized customer experiences, and intelligent manufacturing processes.
Think about a modern automotive assembly line. Computer vision systems inspect quality in real time, predictive algorithms optimize production schedules, and natural language interfaces allow technicians to query complex databases. All of this traces back to these five individuals.
The recognition they've received reflects their extraordinary influence. 4 of the 5 are Turing Award recipients, with Hinton also receiving the Nobel Prize. Their work appears in millions of citations and continues to shape AI's future direction across all industries.
But what I find most inspiring is that each of these pioneers saw beyond the limitations of their time. They imagined possibilities that seemed impossible to their contemporaries, pursuing fundamental questions even when practical applications were decades away.
That's a crucial lesson for our industry, Steve. The autonomous vehicles and AI-powered dealership tools we use today exist because researchers were willing to invest in fundamental science without knowing exactly how it would be applied.
And as we look toward the future of mobility, whether it's fully autonomous vehicle fleets, AI-optimized traffic management, or personalized mobility services, we're still building on the theoretical foundations these 5 minds established.
Their work also reminds us that AI development requires both technical brilliance and ethical consideration. Hinton's recent focus on AI safety, Bengio's work on responsible AI development, and the broader questions about AI's impact on society all stem from recognizing the profound implications of these technologies.
For automotive leaders listening to this episode, I think the key takeaway is understanding that today's AI capabilities didn't emerge overnight. They're the result of decades of fundamental research, collaborative effort, and visionary thinking.
And that same long-term perspective is crucial as we navigate current challenges in automotive AI, whether it's improving the reliability of autonomous systems, addressing public concerns about AI safety, or ensuring that AI benefits enhance rather than replace human expertise in automotive retail.
As we wrap up this special celebration, Claire, I'm curious about your thoughts on what these 5 titans would think about the current state of automotive AI.
I think they'd be amazed by the practical applications we've achieved, but probably not surprised by the fundamental challenges we're still addressing. Turing's questions about machine intelligence, McCarthy's vision of machines that can reason, and the ongoing work on AI safety that Hinton and Bengio are championing, these remain central issues.
What gives me confidence is that their work provides enduring principles for addressing these challenges. The theoretical foundations they established aren't just historical curiosities, they're active guides for current research and development.
And in automotive specifically, we're seeing how their insights apply to new domains. The computer vision principles LeCun established are now being used to analyze satellite imagery for traffic optimization. Bengio's language model research is enabling more natural interactions between humans and vehicles.
The institutional frameworks McCarthy created continue to evolve. Today's collaborative AI research, whether it's open source autonomous vehicle platforms or industry consortiums working on safety standards, builds on the academic and industry partnerships he pioneered.
What I find most exciting is that we're probably still in the early stages of realizing their vision. Autonomous vehicles are just the beginning. We're moving toward intelligent transportation systems, AI-optimized urban planning, and mobility services that adapt to individual needs in real time.
And that brings us back to why we wanted to do this special episode. Understanding where AI came from helps us make better decisions about where it's going. Every automotive executive, every dealer, every engineer working on mobility solutions stands on the shoulders of these 5 giants.
Their legacy reminds us that transformative technologies require both technical innovation and thoughtful implementation. As our industry continues to integrate AI into every aspect of automotive design, manufacturing, sales, and service, we need to honor their example of combining bold vision with responsible development.
Well, Claire, what has left the strongest impression on you from learning about these 5 pioneering minds?
Honestly, Steve, it's the realization that every AI system we discuss on auto intelligence, from Tesla's neural networks to dealership chatbots to predictive maintenance algorithms, represents the culmination of nearly a century of scientific progress. These weren't just individual geniuses working in isolation. They built upon each other's work and created a foundation that continues to support innovation today.
For me, it's the combination of technical brilliance and ethical responsibility that stands out. Each of these titans eventually grappled with the implications of their creations. As automotive leaders, we have the same responsibility to develop AI systems that are not only technically sophisticated, but also safe, transparent, and beneficial to society. The work of Turing, McCarthy, Hinton, LeCun, and Bengio didn't just create the AI revolution, they showed us how to approach it with both ambition and wisdom. Their influence on autonomous driving, intelligent manufacturing, and AI-powered customer experiences will continue for generations to come. As we continue exploring the intersection of AI and automotive innovation on future episodes, we'll carry forward the lessons these 5 visionaries taught us, that transformative technologies require fundamental research, collaborative effort, and unwavering commitment to beneficial outcomes.
Thank you for joining us for this special celebration of the minds who made the AI revolution possible. Whether you're developing autonomous vehicle technology, implementing AI solutions in your dealership, or simply curious about how artificial intelligence is reshaping mobility, understanding these foundational contributions helps us all make more informed decisions about the future.
This episode was produced by the team at Autoagentic AI. Learn more at autoagentic.ai. We'd like to give special thanks to our producer, Barry Hillier, co-founder and CEO of Autoagentic AI, whose vision for responsible AI development echoes the principles established by these 5 pioneering minds. If you'd like to reach out with suggestions for future episodes, thoughts on today's discussion, or ideas about the fascinating intersection of AI and automotive innovation, email us at barry@autoagentic.ai. Barry is always excited to hear from listeners and discover new topics, companies, and people who are shaping the future of mobility. Until next time, this has been Auto Intelligence. Keep innovating, keep questioning, and keep building on the incredible foundation these 5 visionaries created for all of us.